Right now, tonight, the moon is drifting away from Earth. About 3.8 centimeters every single year. Roughly the speed your fingernails grow. It sounds far too small to ever matter. But stretch that tiny number across deep time, and it reshapes our entire world. The length of our day, the steadiness of our seasons, even the survival of life itself. So tonight, let's answer one big question. What really happens when the moon leaves? First, how could anyone possibly measure something so slow? The answer was left behind on the moon by the Apollo astronauts. They placed special mirrored panels on the lunar surface. From Earth, scientists fire a laser at those mirrors and time the reflection. It is precise enough to measure the distance down to a few millimeters. And year after year, that distance keeps quietly growing. The moon really is running away from us, and we have the proof. So what is pushing it away? The answer is hiding in our oceans. The moon's gravity pulls Earth's water into two great bulges. One facing the moon, and one on the far side of the planet. But here is the crucial part. Earth spins much faster than the moon orbits. So our spinning planet drags those bulges slightly ahead of the moon. That displaced water has its own gravity, and it tugs the moon forward. Like an invisible hand, gently flinging it into a higher, wider orbit. But energy is never free. To push the moon outward, something has to pay. And that something is Earth's own spin. The same tidal grip that flings the moon away acts like a brake on our planet. Every year, Earth turns a tiny bit slower. Our days are quietly, relentlessly getting longer. And we can prove it, written in stone and shell. Ancient corals grew a fresh microscopic layer for every single day. Count the daily bands in a 400-million-year-old coral, and the year held more than 400 days. Back then, a single day lasted only about 22 hours. And older rocks, layered by the ancient tides, pushed the story back even further. More than 1 billion years ago, a day may have lasted just 18 hours. Our 24-hour day is a recent gift, and it is still slowly stretching. And this is not just ancient history buried in rock. It is happening fast enough that we have to account for it today. Our finest atomic clocks keep almost perfect time. But the spinning Earth no longer quite keeps up with them. So the world's timekeepers occasionally add a leap second. A tiny, official admission that our planet is winding down. To understand where this is going, we have to rewind to the very beginning. About 4.5 billion years ago, the young Earth was not alone. A world the size of Mars, which scientists call Theia, slammed into it. The collision was so violent it threw a ring of molten debris into orbit. Over time, that glowing wreckage gathered together and slowly cooled. And that, most scientists believe, is how our moon was born. And in those early days, the moon was a very different sight. It orbited perhaps 10 times closer than it does now. It would have loomed enormous, a vast glowing disk dominating the sky. The tides it raised were monstrous, far stronger than anything today. And a single day on Earth may have lasted just 5 or 6 hours. Ever since, the moon has been slowly backing away into the dark. Now here is the part that almost nobody expects. We treat the moon as a pretty light, a backdrop for the night. But it is quietly doing one of the most important jobs in the solar system. Earth is tilted on its axis by about 23.5 degrees. That tilt is the entire reason we have seasons. And the moon's steady gravity is what keeps that tilt locked in place. A stable tilt gives us a stable, predictable climate. Gentle summers and winters that return on schedule, year after year. Crops can grow, civilizations can plan, life can settle into rhythms. Almost everything we take for granted rests on that quiet steadiness. And it has been the moon, all along, holding it together. To see what we would lose, we only have to look at our neighbor, Mars. Mars has 2 moons, but they are tiny, just captured asteroids. Far too small to anchor anything. And without a real stabilizer, Mars has paid a heavy price. Over millions of years, the tilt of Mars has lurched chaotically, swinging from nearly upright to more than 60 degrees. Each swing hurled its climate into violent extremes. Ice that sat at the poles migrated toward the equator and back again. A planet thrown off balance, over and over, with nothing to hold it steady. Now imagine that same fate slowly creeping toward Earth. If we lost the moon's grip, our own tilt could begin to wander. Picture the poles leaning further toward the sun. Ice caps that have stood for ages melting away. Climate bands lurching between scorching heat and brutal cold. The steady world we evolved in would become unrecognizable. So if the moon is leaving, why are we still safe tonight? Because deep time is almost unimaginably slow. The moon is escaping, but only a fingernail's width each year. Its steadying grip will hold for hundreds of millions of years to come. We are living inside a long, calm golden age, and we barely notice it. But will the moon ever truly let go of us? In theory, it would keep drifting outward for billions of years. Eventually, Earth's day and the moon's orbit would settle into perfect step. But that distant future may never actually arrive. Because long before the moon can finish its slow escape, the sun will change. In roughly 5 billion years, our sun will start to run out of fuel. It will swell into a vast red giant, hundreds of times larger than today. Its outer layers may reach out and swallow the Earth and the moon together. So the moon never really abandons us. We simply run out of time first. So the next time you glance up at that pale, familiar disk, look again. It is not just decoration hung in the night sky. It is the anchor that steadied our world long enough for life to take hold. It set the length of our days and the rhythm of our seasons. And right now, in complete silence, it is slowly slipping away. The universe is full of quiet questions like this one, hiding in plain sight. If you want to keep finding them, subscribe to Knowvable, and we'll see you under the next big question.